for coming today. And thank you to Journey Santa Fe and Wilderness Guardians for sponsoring this presentation. This is the Santa Fe National Forest near where I live. Almost every day I hike up the ridge from my home, and when I get to the top of the ridge, this is what I see. And I feel wonder, happiness, peace, a sense of expansion, and a sense of connection with the web of life that supports us all and provides balance in an often unbalanced world. And I believe that the trees form a web of life themselves. Newer research indicates that they are connected and interdependent under the soil and live and thrive in communities. Together they form a canopy that keeps the forest cooler, provides moisture, and provides habitat for wildlife. And I know that living in a forest community, even during fire season, I'm immensely safer up by the forest than I am driving down in Santa Fe. Few people have died in wildfire in New Mexico. Driving in town is dangerous. And yet we do it all the time without fear. Why so much fear about fire? Fire happens in the forest. Fire is natural to the forest and is part of the natural cycles of the forest. We can protect our homes with almost not quite 100% certainty. A few homes burn, but with reasonable fire mitigation measures. If there's a fire in the forest, it does not have to burn our homes. The U.S. Forest Service, along with a collaborative called the Greater Santa Fe Fireshed Coalition, is proposing to do mechanical thinning and prescribed burning on much of 107,000 acres of local Santa Fe area forests. And the first two projects have already started. Prescriptions typically call for the removal of well over 90% of trees. Some people call that tree clearing, not thinning. It causes a lot of damage to the forest. The forest isn't even recognizable by the time you're done with that. Newer research indicates that thinning out in the forest away from homes does not keep us safer from fire. In fact, in many cases, it can make the forest more in danger of fire. And Chad will talk about that research today. In the Santa Fe National Forest, we have observed that thinning projects can leave highly damaged ecosystems, including damage to the forest floor, erosion and soil compaction, insect and disease outbreaks affecting the trees that are left behind, generally weakened trees, and damage and disruption to wildlife habitat. These projects can leave those who want to find beauty and peace in the forest feeling deeply sorrowful when they come upon a sea of stumps and slash that look like there had been a war against the trees. In our warming and drying climate, the forest does not seem to be recovering well from impacts, as it was more able to even a decade ago. And many of the projects are planned to occur in inventoried roadless areas of the National Forest that are meant to be highly protected from impacts. Prescribed burns happen much of the time in our area during the spring and the fall. Prescribed burns are smoky, low-temperature fires using chemical fire accelerants. And many people in Santa Fe experience severe health effects from the smoke. For all of this, thorough analysis is needed. And there's a very good process to do that with. It's called an environmental impact statement. An environmental impact statement would allow us all to participate fully in the process, would analyze the cumulative impacts of all the different parts of this large-scale project, and would require adverse impacts to be mitigated. It's a powerful process when done sincerely and well. As a community, we need to really focus on what is happening to the Santa Fe National Forest. Please be engaged, be for the forest. Tell your elected representatives and anyone else that we want an environmental impact statement done for the entire Fireshed Field Treatment Program. I'm really happy to introduce our speaker, Dr. Chad Hanson. who has spent decades trying to protect the forests of the western United States. His desire to protect our forests started when he hiked the Pacific Crest Trail from Mexico to Canada with his older brother in 1989. During that hike, he witnessed firsthand the devastation of the rampant commercial logging in our forests in California, Oregon, and Washington. That experience caused him to become a true guardian of the forest. He's the co-founder of the John Muir Project of the Earth Island Institute and National Director of the Sierra Club. He's the author of a large-scale research study that indicates that forests that have not received field treatments burn less severely than forests that are treated. And he's the author of the book, The Ecological Importance of Mixed Severity Fire. Thank you, Ms. Chad.
Thanks. Perfect. Thanks a lot. All right, well, thank you for the invitation. I appreciate the opportunity to come out and talk to you today. I'm Chad Hanson. I'm a forest and fire research ecologist with the John Muir Project. I'm also a national director of the Sierra Club. And my research focuses on fire history and natural succession after fire and wildlife species that live in the forest and depend in many cases on post-fire habitat. So I'm going to be talking today and focusing on patches of higher intensity fire, particularly in ponderosa pine forests. Can everyone hear me okay? Okay. Because that's something that I think is the least understood in this whole conversation. I think people generally understand now that fire is a natural part of our forest, but the greatest understanding is with regard to low intensity fire, surface fire, where most of the mature trees survive and the fire just sort of consumes pine needles and twigs and small trees in the forest floor. And that's important too, and that's a critical part of the forest ecosystem, but it's also a little bit more complex than that as well, so I'm going to be delving into that. We've had this notion for a long time that the only healthy forest is a forest that's really dominated by live green trees. And obviously live green trees are a critically important part of the ecosystem, but they're not the only part of the ecosystem. And a forest ecosystem is made up of different structural components, live trees being one of them, but also snags and down logs, shrubs, young regeneration, understory trees. And so I'll be talking about that. So I'm going to start off talking about a study that myself and some co-authors, Dennis Odian and others, published 4 years ago. And we tried to pull together all the different lines of evidence and the different scientific studies that have been published, particularly in the last 15 years, that look at whether or not fire history was a little bit more complex in ponderosa pine forests historically than we thought. We know low intensity fire, surface fire, was a dominant influence. But was it the only influence, or was it a little bit more complicated than that? And so we looked at this, we looked at paleoecological stuff, basically charcoal sediments going back thousands of years, studies that are published on that can track levels of fire in different periods of time throughout history. Historical records from the 1800s, from early government agencies, stand age analyses about different stand ages in areas that had never been logged before. And what we found is that it was a complex mix. These forests were dominated mostly by low and moderate intensity fire, but there was a significant component of high intensity fire, where the fire kills most or all the trees, burns hotter. And the question is, what does that mean in forest ecosystems? And in particular in ponderosa pine forests in the western US and in the Southwest in particular. Does that mean that area has been lost or destroyed, or is it something a little bit different than that? We also found, by the way, that there's been a decline of high-intensity fire since fire suppression began a century ago, and that's a key point I'm going to be coming back to. A whole group of scientists did a response paper, and they agreed with us mostly on a key aspect, which was the stand age analysis. Didn't agree entirely, which scientists rarely do. but they didn't challenge most of the lines of evidence or most of the conclusions. And so their basic conclusion was, looking at the evidence, high severity fire was undoubtedly a component of fire regimes in ponderosa pine and dry mixed conifer forests historically. So there is now a broad consensus among scientists that there was always a component of high intensity fire in these forest ecosystems. And that's really important to understand, because the belief that that's unnatural or destructive is driving a lot of the forest management activities we're seeing right now. And that has costs both ecologically and in terms of how resources are allocated in the landscape, where they could be allocated to protect communities and focus on protecting homes from wildland fire. So the same group of authors in the study, and these are mostly a lot of Forest Service scientists, university scientists, they said, when different weather conditions were occurring, the more severe fire weather, topography, there was always a variation in how often fires would occur in different periods of time and different stands, and you can get those higher intensity fire patches. The forests were not all homogeneously low intensity, low density historically. There were low density areas in the forest, and there were very dense areas. So it was always a mix, and conditions sometimes were right to have more high intensity fire, including some larger patches. And one of the places where there's still uncertainty and disagreement is in the really large patches, over 1,000 hectares, which is about 2,500 acres and larger. And this is one of the places where this other group of scientists that responded to us, as Stevens et al., questioned whether or not they didn't dispute that those patches existed and occurred historically before fire suppression. But I think they're raising the question, do we possibly have more now? Do we have the same number? They think that's an important question to address, and I agree. So I'm going to talk about some of the places where we have perceptions about fire that they're not always consistent with the way fire is happening on the landscape. Because I think that's really important, especially when it comes to big fires, like the Wallow fire that happened in eastern Arizona in 2011. Other big fires that have happened in recent years, there's a perception that these fires are mostly or almost entirely crown fire, mostly high intensity, and that all the trees are killed across the entire landscape, or across almost all of it. In reality, the big fires are predominantly low and moderate intensity. Different definitions of high intensity, or some people call it high severity, which basically means the proportion of the trees that are killed. Different definitions can give you slightly different results, but by any definition, it's mostly low and moderate, which are the green and yellow areas, the red areas being the high intensity places where most of the trees are killed. And this is consistent with the paleoecological studies, using carbon-14 dating of charcoal sediments to go back thousands of years. And it turns out that in various points throughout history, there have been periods where there's been relatively more high-intensity fire, periods where there's relatively less, but it's always a component of the forest. Another very large fire. These are fires over 200,000 acres in recent years in the Southwest. Again, significant high-intensity fire patches, but mostly low and moderate. More fire history work from this one from Tom Swetnam, Roos and Swetnam, and another paleoecological type study. This is a reconstruction actually that goes back 1,400 years or so. And there was a period of time during the 14th and 15th centuries where there was quite a bit more high-intensity fire. We found that in our study, Odian et al. 2014, that there was elevated levels in the late 1700s and early 1800s, and that the current stand gauges are reflective of that. So, similar thing, Horseshoe 2 fire, southern Arizona, 2011, 222 or 226,000 acres, I believe. Again, significant patches of high-intensity fire, but mostly low-moderate. And this is something that we find, and no matter how big the fires are, almost in every case, you get mostly low and moderate intensity effects. Right now, we have fire frequency, what we call rotation intervals in technical terms, of high-intensity fire, specifically high-intensity fire, of about 900 years in ponderosa pine forests in the Southwest. If you include all fire intensities, it's of course more frequent than that, but it's still much less frequent than it was historically. So we actually have less fire now than we did before fire suppression. A lot of people don't realize that. We actually have a deficit. And this is the key point. We don't want too much, we don't want too little. And right now, we're actually on the low end of things overall, especially with regard to low and moderate intensity fire, but really fire in general. I'm going to talk a little bit about less conscious fire, because this is one where it's still majority low and moderate intensity, but the percentage of high intensity was higher here than the other large fires recently. And one of the patches in particular in the south, that larger red area, about 20,000 acres. Some people define it a little bit more broadly and call it 30,000 by including some of the moderate intensity areas. But pretty big area. And the question is, what does that mean ecologically? And I want to talk about this in particular because this is an area where there's a widespread perception that the fire burns so hot that it sterilizes the soil and nothing will grow. And it's this vast barren wasteland with no trees, not a single live tree across 30,000 acres. And it's understandable people would believe that. There's a lot of fear and misunderstanding about especially big fires like this. But I want to talk a little bit about what I'm finding out there on the ground. I was just out there yesterday, and these pictures I took just yesterday. What we're seeing is abundant and vigorous regeneration of aspen, gamba oak, locust, and also conifers. But the aspen is something that's really key because aspen has a very close relationship with high intensity fire in particular. In fact, aspen really depends on patches of higher intensity fire to maintain itself on the landscape. In a natural succession, after the conifers grow in and get dense enough and overtop the aspen starts to die back. It needs a lot of sunlight. And this is its moment in the sun, really, next few decades for the aspen to thrive. And high intensity fire is what makes that possible. Aspen's a very important habitat type. And what we're seeing out there is that these pictures are all in that largest high intensity fire patch in Los Conchas. Again, I took these yesterday. We're seeing out there just amazing aspen regeneration. We're at 7 years post-fire now, and in many cases it's 15 feet tall or taller. In some cases it's even taller than that. And one of the other things that's interesting is that throughout this 20 or 30,000 acre area, depending on how broadly or narrowly you define it, it's not an area where all the trees are killed. It's an area that has lots of little patches and some not so little of live trees scattered throughout, what I call inclusions of low and moderate intensity fire. And these are seed sources. They're also part of what we call habitat heterogeneity. And so it turns out this landscape, instead of being this homogenizing thing with nothing but dead trees across the whole landscape, what we have is this complex mix of pockets of surviving trees, stands of dead trees, what we call snags, regenerating aspen, gamba oak, and conifers. And again, some of these pockets are really small, they're 1/10 of an acre, some of them are a couple dozen acres. And we find them throughout the entire fire area. It's really difficult to find areas that are very far, more than a few hundred meters away from a pocket of live trees in this patch. And what we're also seeing is some really nice natural regeneration of conifer seedlings and saplings already beginning. In some areas it's already begun. A few areas that it began 2 or 3, 4 years ago, and in some it'll begin in another 3 or 4 years. So it doesn't all happen in the first year. Sometimes people come into a large high intensity fire patch a year or 2, or even 6 or 7 years, 8 years post-fire, and they think it's been type converted to non-forest because they're not seeing the regeneration. Sometimes it doesn't start until 10 or 12 years post-fire. But it's already starting. And it's really interesting and vigorous in many places. In some places it's still very oak and aspen dominated, and it will remain that way for another several years before the conifer regeneration starts. But in other areas it's coming in pretty vigorously already, and that process is going to accelerate. So one of the other things that people see out there is this on the fire-killed trees, the snags. And it looks like someone stood out there with a rifle and shot up the tree. But what that is a wood-boring beetle that's bored into the tree, and a woodpecker that's actually gone in after the larva. The way this works is, when a patch of high-intensity fire occurs, there are many species, native species of wood-boring beetles that have evolved to detect fire by heat or by smoke, depending on the species. And these beetles need fire-killed trees to reproduce and to maintain their populations on the landscape. They make a beeline for these fire areas. They lay their eggs on the bark of a fire-killed tree, the charred bark. The larva develops, it bores through the bark into the wood of the tree, and the larva develops into an adult over the course of a year, 2 years, sometimes longer. And that is the primary food source for the woodpecker species that live in these forests. The woodpeckers eat thousands and thousands of these wood-boring beetle larvae every single year. And they also, so they depend on these fire-killed trees for food, but they also depend on them for nesting because dead trees are softer than live trees. And so the woodpecker species are monogamous. Every spring the male will excavate between 2 and 4 new nest cavities, and the female picks the one she likes the best, and that's where they raise their young that year. And all the cavities that they create, but they don't use in a given year, are available for all the other cavity nesting species in the forest that need cavities to survive and reproduce, but can't make their own. So bluebirds, nuthatches, chipmunks, wrens, dozens and dozens of bird and small mammal species that depend on cavities. And so if you don't have natural disturbance processes, killing patches of trees, whether it's drought and native bark beetles, or whether it's patches of higher intensity fire, if you don't have that, you don't have the beetles. If you don't have the beetles, you don't have the woodpeckers. Without the woodpeckers, you don't have the cavities, and now you're having a problem with your populations of bluebirds, nuthatches, and many of the cavity nesting small mammals. And if that happens, you lose your food source for goshawks, for spotted owls, etc., and on and on. So this is an interconnected system that's actually very rich and biodiverse. This is a hairy woodpecker, by the way, foraging on a large snag there on the left middle of the screen. You also have a lot of wildflowers that bloom in these areas, and that attracts a lot of flying insects, native flying insects, which in turn provides food for fly-catching birds and bats. And so that's another connection. A lot of these birds, many of them nest in the cavities in the snags, but a lot of them nest in the shrubs in the understory. And so that's a whole community as well. And a lot of those are actually in trouble because of fire suppression and post-fire logging activities. And another key aspect of this is the small mammals. Because of the snags and the down logs and the regenerating understory vegetation, that's incredibly good habitat for small mammals. In fact, the small mammal prey biomass is 2 to 6 times higher in these mixed intensity fire areas than it is in unburned mature forest. And that creates great habitat for foraging for Mexican spotted owls, for example. We call this the bed and breakfast effect, because they nest and roost in areas that are unburned or lightly burned or moderately burned, but they go out of their way in many cases to forage in the fire areas because that's where a key food resource is. And so if these areas are not logged after fire, we often see spotted owl populations increase. And we saw that in the Horseshoe 2 fire, big fire, no post-fire logging, mostly protected landscape, and spotted owl populations thrived after the fire. Native fish often thrive too, and this seems counterintuitive because we kind of have this idea that if a fire occurs, especially if it burns hotter, you're going to get a pulse of sedimentation washing into the stream, and that's got to be bad for fish. You do tend to see a temporary reduction in fish populations, but by 2 or 3 or more years post-fire, they typically go up to pre-fire levels and often surpass it, because the pulse of sedimentation can create good spawning grounds, and also the fire itself increases the aquatic insect prey, so they have more food to eat, kind of like the spotted owls in a way. So bottom line is this unique habitat type that's created by higher intensity fire, where many, if not most or all the trees are killed, we call this snag forest habitat. And it turns out it's comparable to old growth forest in terms of native biodiversity and wildlife abundance. This is a critically important forest habitat type. So instead of being destroyed or lost, the forest is actually, this is actually a critically important forest habitat type that needs to be part of the mix. Again, we don't want too much, we don't want too little, but I guess my key message here is what's going on right now in the forest is not a disaster. We don't need to think of it as loss or disaster or something we need to manage the entire forest or log extensively across the landscape to prevent, because this is actually, these areas in many ways are ecological treasures. And we're seeing, again, very vigorous regeneration. This is a study that came out last year, and it's a little hard to read, but basically these are areas close to live trees, and these are areas that are deeper into the interior of large high-intensity fire patches. And it just shows that you've got, on average, higher levels of natural conifer regeneration where you're closer to live trees. That makes sense. But in the deep interior areas, you're still getting conifer regeneration. So the belief for a long time was that in those areas, if you're more than 50 or 100 meters away from live trees, conifer regeneration won't happen. Those areas have been deforested, and they'll remain deforested for centuries if we don't artificially plant them. Turns out that's not the case. It doesn't always happen initially. Sometimes it takes 7, 8, 9, 10 years for it to begin. But when it does, it's actually quite significant. But it's a little bit lower density. It's a little bit more open. And in fact, in many ways, you can think of this as the kind of origin story of the kind of the open forest condition, because that's what's happening here in terms of natural succession. And the authors concluded that these stands are actually, in many ways, could be argued to be more resilient to climate change. And that kind of mix of forest conditions and heterogeneity, including those open areas, is creating some really interesting stuff on the landscape. So again, not a disaster, not something we need to think about as a loss of the forest. Other research coming out that's, again, seemingly counterintuitive. This is a large analysis across the western United States from Kaiser and Westerling, and they actually found that even though annual acres burned are incrementally inching upwards, which they are, and in part that's influenced by climate change and rising temperatures, we still have a lot less fire now than we had historically, but as annual acres burned are inching up, fires are not getting more intense. So the proportion that burns at high intensity is not increasing along with the acres burned. It's just sort of creeping back closer and closer a little bit to where it used to be over a century ago, even though we got a long way to go. So I want to talk briefly about some issues that are oftentimes not part of the conversation when it comes to thinning. I think we need to have an open and candid conversation about this. You can reduce fire intensity if you thin small trees and follow it up with prescribed burning. There's a lot of studies on that, but that's not the only question out there. You have a very low probability of a thinned area encountering wildland fire during the effectiveness period after thinning, which is typically about 15 years. It can be 20, it can be 10, depending on the ecosystem. But it's a very, very, very low probability of that area encountering fire during that period of time. So what often happens is then it's thinned again, and again, and again. And as a result of that, the tendency is that these areas actually thinning, if it's done to reduce fire intensity or curb fire, it results in a net reduction in forest carbon storage and a net increase in emissions, simply because so many trees are being killed and removed by thinning without the area even burning or reducing fire intensity. So that needs to be kept in mind, because some of the early studies, a lot of them, assumed a 100% chance the area would burn within 15 years after it's thinned, which rarely happens. The other thing that's important is that the concept behind it is to prevent high-intensity fire from happening. There are areas where you do want to prevent high-intensity fire, especially near homes. That's critical. It's public health and safety. Okay, that has to be a priority. But out in the wildlands, if we don't have an excess of fire, then it raises more of a question about why we're trying to further suppress fire when we have a deficit. And especially now that we know that there are entire groups of wildlife species that depend on snag forest habitat, many of which are found mostly in that habitat type, and very little in areas of low intensity or unburned forest. I want to briefly talk about some research, thank you, from Parks et al. 2018. It's a modeling study, and they reported that fuels are more important in terms of determining fire intensity than climate and weather. One aspect of that that's a problem is that they didn't have any stand data to make that judgment in terms of what the stand conditions were, and they didn't actually have fire weather data that correlated to the day a given stand burned in the fire. And they acknowledged that that minimized the influence of, it basically reduced the influence of weather in what they reported. So when studies have looked at the actual fires, when they have stand data, and when they actually have weather data that's correlated to when a particular stand burned, weather is overwhelmingly the most important factor. Oftentimes topography too, but weather is much more important than how dense the forest is, in other words. Interesting stuff about water. Thinning can slightly increase water yields. However, it mostly comes in the form of flooding in wet years, which is not what we want, as opposed to a reliable increase in flow in dry years. So it's something to keep in mind. Conversely, high-intensity fire patches can create a sort of wetland effect that retains a lot of moisture and actually can increase water yields in a more stable way because of all that understory, lush understory vegetation. So again, counterintuitive, but that's what the research is indicating. Also, in terms of the sediment from high-intensity fire and any increase in flooding, it tends to be fairly short-lived because of all that vegetation that regenerates naturally in the understory, which is interesting. A little note about prescribed burning too. It tends to be applied as a homogeneous, low-intensity prescription. Again, there are places where that's appropriate, especially if you're trying to protect a community. But out in the wildlands, you can't mimic the natural mix of habitat heterogeneity that you get in a wildland fire with prescribed burning. The other problem is that it's done in the spring or in the fall when conditions are wet, outside of fire season, and the wood-boring beetles are not adapted to be active during that time, so they don't tend to colonize the fire. So the woodpeckers show up expecting they're going to have food, but the food isn't there, and it can create an ecological trap that causes the woodpecker populations to plummet, and that has impacts on secondary cavity nesters, and you get this whole chain of effects that can happen. So again, it can have its time and place, but as a landscape prescription, it's not a good idea. It can have unintended consequences. So what does it all mean from the standpoint of allocating resources and attention? I think the answer is this. We need to appreciate the role of fires in our forests, including large mixed intensity fires. We need to appreciate the role that it plays in creating habitat and the fact that forests do regenerate, even though they don't always do it on according to human timelines or expectations. Sometimes it takes a little longer. And instead of focusing our resources and attention on backcountry fire suppression and logging projects or other tree cutting and forest management projects out in the forests and in roadless areas, instead of doing that, we need to focus our resources on protecting homes. And we know how to do that. It's all about making homes more fire safe, fire-resistant roofing, rain gutter guards to keep the pine needles and leaves from accumulating next to the roof, and exterior vents to prevent embers from floating into an attic space, for example. And then, in addition, defensible space within 100 feet of homes, helping homeowners remove the lower limbs on the mature trees, but keep those big, mature trees standing, and then remove many of the small trees and shrubs and grasses next to the home. When that's done, over 90% of homes will survive wildland fire, even intense fires. And in many cases, over 99% of homes, in some examples, will survive wildland fire. So we know this is effective, and we talk about this in the book. In chapter 13, we have a whole chapter devoted to how people can live, coexist and live safely with wildland fire. That's where our focus needs to be. And forest management beyond 100 feet from homes has no additional benefit to protecting homes. So we have a choice to make. Are we going to continue to manage the forest, trying to stop fire or curb fire in ways that really aren't consistent with a lot of things we're learning about forests and fire? Or are we going to focus on protecting homes and protecting lives and structures in a way that we know is effective? I suggest we focus on the latter. And I'll just leave with this, finish with this one kind of big picture thought. What is a forest? Again, we have been told for many, many years that a forest is a collection of live green trees. And that's, of course, part of it. But it's also this sort of messiness, the snags, the down logs, the shrubs, the understory trees of different species. That messiness is biodiversity. That's really where your wildlife abundance and your diversity comes from. A forest, an area that has relatively little but live, mature, widely spaced trees and not much else, it doesn't tend to be a very biodiverse habitat. And these areas of snag forest habitat that, with all the natural regeneration of vegetation, the snags and the down logs, this is a forest too. It's a very important forest habitat type. And once we understand that that's all part of the mix, I think it opens up more options in terms of how we allocate our resources and how we focus our attention. Thank you.